Today, I would like to show you Onshape, the first full cloud professional 3D CAD system that runs on any modern browser or mobile device. The advantages your design team gets from using a full cloud CAD system are huge, and today, we're going to discuss why. The first thing to remember about Onshape is there's never a need to download, install, or update. Accessing your CAD data is as simple as logging in from any modern browser, including Chrome, Opera, Firefox, and Safari. Once logged in, you'll be taken to the Documents page. Think of the Documents page as a list of your various projects. You can see we have a document called Leaf Blower, which we've recently been working on. So let's open that up. Now that we have the document open, we can begin modeling. You can see that the majority of our leaf blower is already finished, but we have one important part left to create, and that is the connecting rod for the engine. So let's create it. I'll click the plus icon in the bottom left corner and create a new part studio. So now we have a blank part, and we are ready to start modeling. Before we begin modeling, there are three important pieces of the interface that I want to discuss: the toolbar across the top, the feature list on the left, and the tabs across the bottom. The toolbar across the top is of course where you will find your various tools. The toolbar will change depending on what you're doing at that time. So if you're in a sketch, you'll see sketch tools. In an assembly, you'll see assembly tools, and so on. Don't be fooled by the toolbar's simple appearance. As you start digging into each command, you'll find a myriad of options that will make you feel right at home if you're coming from another CAD application. The second piece of the interface that I wanted to mention is the feature list on the left. Here you can see all the features that make up that model. This should be a familiar concept if you've come from other professional 3D CAD systems, as many of them have something similar. The last piece of the interface to mention is the tabs across the bottom. Each tab has a purpose. You'll have tabs for parts, like our new part. You'll have tabs for assemblies, like the top-level leaf blower and its various sub-assemblies. And you'll have tabs for drawings. You can even import files from other CAD systems, or even just project-related files, and store them in a tab in the document. Onshape supports many different file formats for both import and export, so if you're working with other CAD systems or sent files created in other CAD systems, chances are we can import and work with that data. So now that we've discussed a few of the important pieces of the interface, let's create our connecting rod. We'll start a sketch on the front plane by left-clicking it in the graphics and clicking the sketch button in the toolbar. Now we've started a sketch on the front plane. Notice that our toolbar is now showing sketch commands. There is one final step that I need to do before I begin sketching, and that is rotate the view normal to the sketch plane. For this, I'm going to use the right-click menu. The right-click menu in Onshape is an important piece of the interface that gives you a context-sensitive list of options to choose from. So if I right-click in the empty graphics while in a sketch, I see an option to view normal to sketch plane. So now that we're normal to our sketch plane, we can begin. I want to start with two simple circles, so I'll select the circle command from the toolbar and move my cursor to where I want to place the circle, in this case the origin. Notice that as I move my cursor, I see inferences to the origin appear automatically. If I move my cursor over the origin, you'll see a flag appear indicating that I'm automatically creating a constraint to the origin. To create my circle, simply left-click to define the center, move my cursor out, and left-click to define its size. And the next step is to create another circle, aligned vertically with the last one. You can see as I move my cursor, I automatically get that vertical inference to appear. I'll simply left-click to place the center, and left-click to define its size. So we've placed our first two circles, but we haven't yet added dimensions to them. To do this, we'll select the dimension command from the toolbar, and left-click the circle, and left-click to place the dimension. Enter a value and hit enter, and the circle now has a dimension. One thing worth mentioning is you will notice our first circle is now black, while the second circle is still blue. In Onshape, you get visual cues as to the level of definition in your sketch. Fully defined sketch geometry will be black, while underdefined sketch geometry will remain blue until it is properly constrained. So you're constantly aware of what's needed in your sketch. If I add a dimension to define the diameter of the second circle, and add a dimension to define its distance from the origin, my entire sketch will be fully defined. We want to sketch two more circles at the center of the previous two, and just like we did before, add the appropriate dimensions and/or constraints. So we've created and defined our circles. The next step is to create a line that joins them. Before I do that, I want to sketch a construction line between the center of the two circles. I'll select the Line command from the toolbar, click Construction, then left-click the center points of each circle to create a construction line that joins them. Now that we have our construction line, let's create a line that joins the two circles. Again, I'll select the Line command from the toolbar and move my cursor over the first circle. And notice that as I move my mouse over the circle, I again get a visual cue that I'm creating a constraint to that circle. I'll left-click, then move my cursor to the second circle, where again, I can automatically create a constraint attaching it. Simply left-click one final time to finish. So now that I've created a line that joins the two circles, I need to mirror that line to the other side. I'll select the Mirror command in the toolbar, select the line I want to mirror about, which is our construction line, then choose the line I want to mirror. You can see the line is mirrored to the other side. We'll add a dimension to define the width, and we're ready to extrude our sketch. Notice in Onshape, I'm not concerned about trimming individual sketch entities to create a single enclosed contour like I would be forced to do in many other CAD systems. In Onshape, I can leave the sketch as it is, go straight to the Extrude command, and Onshape will automatically select the correct shape to extrude. In fact, in Onshape, I can extrude the entire sketch as you see here, or I can clear that selection and choose any piece of the sketch that I want to extrude. This means I can use the same sketch to drive several features. In this example, we want to extrude the connecting rod ends to a depth of 7 mm. I'll select the green check OK, and we have our first feature in the feature list. Now we want to use the same sketch to drive the feature that joins them. So we can show the sketch in the feature list by clicking the eye next to it, and again go back to the Extrude command. This time we'll select the centerpiece of our sketch and extrude it to a depth of 3.5 mm. The next step for our connecting rod is creating a recessed slot in the center. To do this, we can click the face of the centerpiece and start a sketch by clicking the sketch icon in the toolbar. Now that we're in a sketch on that face, we can sketch a construction line that will be the center of our slot. I'll select the Point command from the toolbar and left-click to place a point at the center of the construction line. Then I can easily create a constraint between that point and the midpoint of this centerpiece by left-clicking each and selecting the horizontal constraint from the toolbar. Then we can add a dimension for the length. To create our slot, we select the Slot command from the toolbar and left-click our construction line. The last step is to define the size of our slot. Now we're ready to create our cut. In Onshape, you won't find an Extruded Cut button in the toolbar. Instead, this is simply an option within the Extrude command. So I'll click the same Extrude command from the toolbar, but this time I will choose the option to remove, and then enter in a depth. Finally, we can use the Mirror command to easily mirror this cut to the other side of the connecting rod. Now, we're nearly finished with our connecting rod, and up to this point, if you've come from other professional 3D CAD systems, much of this should look familiar to you. We've built Onshape in a way that makes it easy to transition from other CAD systems, but there are a lot of things you can do in Onshape that you can't do in other CAD systems. So let's get into a few of them. One of the biggest advantages of a full cloud CAD system is the ability to collaborate in real time. In traditional file-based CAD systems, if you wanted to work with others, you had to send them a copy of your file. They then would work on that copy while you're in the dark on the progress being made. It wasn't until the copy was sent back to you that you see the work and how it might impact your design. This leads to a very serial workflow where you're left waiting for files so that you can move on. We've taken an entirely different approach. In Onshape, if you want to collaborate with others, you simply click Share in the top right corner. Enter in their email address and define their permissions. The permissions you give them can vary from full edit and copy permissions to simply viewing the model. Click Share, and the person you've shared with gets an email with a link to the document. They do not need to download and install anything, or worry about if they have the correct version of software. In seconds, the person you've shared with is looking at the same model as you are. Any changes made by anyone in the document will update for everyone instantly. So you never have to worry about sending files back and forth. When someone else is working in the document, you see visual cues that they are there. You can see what tab they're in, and you can even see when they're adding features live. Here you can see the person I'm sharing with is adding a new feature to our connecting rod. The moment that person adds the feature, it instantly updates for me. Onshape is the only CAD system in the world that gives you this ability to collaborate with others in real time. Here we can see the person we've shared with added fillets to our connecting rod. So we've finished the design on our connecting rod and we're ready to take it to the next step. Before we move on to assembling the connecting rod in our engine, let's take a moment to discuss data management. In many traditional file-based CAD systems, it's very important for you to remember to save. Otherwise, you risk losing work. You'll notice at no point in designing our connecting rod did I click Save. In fact, in Onshape, there is no save. And that's because everything we do is automatically saved the moment you create it. This means you never have to worry about losing work when you forget to save, or worse, your computer crashes. These things can lead to considerable downtime or rework in a traditional file-based CAD system, but in Onshape, you don't lose anything. Not only does Onshape automatically save, but it also lists every change made to the document in the history. This means you can open the history and see who made what changes and when. This gives you a complete audit trail of your design going back to the moment it was created. In fact, if you don't care for a certain change, you can easily pick a point in the document's history and restore it. In a traditional file-based CAD system, if you wanted to do this, you would need a complex, expensive PDM system. But in Onshape, this is built in as core functionality at no additional cost. So we've built a simple part and discussed some of the ways that Onshape differs from other CAD systems. Now let's take a look at some of the ways Onshape has improved the experience of creating assemblies. For this, let's switch tabs to our short block assembly. The next step for us is to insert our connecting rod into the short block assembly and mate it into place. So we'll click the Insert command from the toolbar and browse to our connecting rod. Left click to select it and left click to place it. Now we're ready to mate it into place. Mates in Onshape are a bit different than those in traditional CAD systems. In a traditional CAD system, to mate a part into place, you would use a combination of faces for reference. This means to mate a bolt to a hole, for example, would often take 3 different mates. With Onshape, we wanted to take a different approach that simplified this process. The key to the approach is the mate connector. In Onshape, when we want to mate a part into place, we simply select the mate from the toolbar, then select a mate connector on one part and a mate connector on another part. Onshape will then bring those 2 parts together with that single mate. The movement that you get between the parts is determined by the type of mate that you choose. So mating a bolt to a hole in Onshape is just 1 mate rather than 3. This means we can mate our connecting rod to both the crankshaft and piston with 1 mate on each end. No need to use a combination of faces. In short, this means your assemblies in Onshape will have much fewer mates, making them easier to understand and troubleshoot if there are any issues. So we've created our connecting rod, mated it into place, and discussed some of the ways that Onshape has improved the design experience for engineers. But what about drawings? Let's create one. Onshape drawings are integrated right into the document just like parts and assemblies. To create a new drawing, I'll click the plus icon in the bottom left corner and choose Create Drawing. Then choose a template. A new tab will be created with my blank drawing. From here, it's easy to choose my part or assembly and begin inserting views. Projected views, auxiliary views, detail views, section views, and more are easily created with a few clicks. Once I've established my views, it's easy to insert dimensions and add notes, balloons, or a bill of materials, and automatically populate my title block with properties from the document. So we've created our connecting rod, assembled it into our assembly, and created a drawing of it for manufacturing. We've taken this design from start to finish and discussed some of the ways that Onshape has revolutionized the design experience, but we're not done. I mentioned before that Onshape has done many things that you simply can't do with any other CAD system. One more example of this is the Onshape mobile app. The Onshape mobile app for iOS and Android is a full functioning CAD application, not simply a viewer like you'd find in many other CAD systems. This means you can create and edit sketches, features, parts, and assemblies from your phone or tablet. No need to be in front of your desktop. One final thing to mention, after you've finished your design, it's common to need to do things like test the design's strength with finite element analysis or generate toolpath with CAM software. How do we do this in Onshape? All of these apps and more are available in the Onshape App Store. So if you're looking for rendering, CAM, finite element analysis, fluid dynamics, and more, check out all the apps available in the Onshape App Store. The combination of Onshape and the apps available in the Onshape App Store mean you can take your design from concept to reality easily.